Today we're going to talk about a different kind of quadrilateral, a trapezoid. And by definition, so this is the definition of a trapezoid, is that it is a quadrilateral with exactly one pair of parallel sides. So you see the figure on the left, we have the two parallel sides, and then here on the figure on the right, our two parallel sides are on the right and the left. Now, one thing I do want to point out to you is that we do call these sides different names. So the two sides that are parallel, we call those the bases, and the two non-parallel sides we call the legs. So even on the figure on the right, our bases here are not top and bottom. They are the right and left because they are the parallel sides, which makes the top and bottom sides the legs. So again, the bases are the parallel sides, the legs are the non-parallel sides. And then we have a specific kind of trapezoid, which is an isosceles trapezoid. An isosceles trapezoid just means that it's a trapezoid that has congruent legs. So we're making some assumptions here that these two lines, AB and CD, are parallel to one another. And if this is an isosceles trapezoid, that means that the legs are going to be congruent. And again, we see another figure that looks like it's kind of turned on its side. And I'm going to assume that EF is parallel to GH. And if this is an isosceles trapezoid, that means that my legs are going to be congruent. Now we do have a theorem about our isosceles triangle. And what it tells us is that the base angles of an isosceles trapezoid are congruent. So if I'm talking about the base angles, if I look at the figure up above, these two angles, angle A is going to be congruent to B. And we also know angle C and angle D, they're also considered base angles. So those are also going to be congruent. And then if I look at the figure to the right, we could say that angle E, I'm going to put three arcs there, is going to be congruent to angle F. And goodness gracious, we're going to have four arcs. 4 at angle H is congruent to angle G. But again, we know that base angles in an isosceles trapezoid are going to be congruent, kind of similar to an isosceles triangle. So now we're going to go and talk about the median of a trapezoid. Now, I want you to be very clear here. We could also call this a mid-segment because it is very similar to a mid-segment of a triangle. Now, the median or the mid-segment of a trapezoid is the segment that joins the midpoints of the legs. So we'll talk about how this differs from and is similar to medians and mid-segments of triangles. So here, again, the median or the mid-segment of a trapezoid, we've got our two bases right here that are parallel, and then we have our legs. And this median or mid-segment is going to join the midpoints of the legs. So here I'm going to draw this segment that I'm going to show on my figure joins the midpoints of the legs. So I'm going to call the midpoint of AC point M and the midpoint of BD point N. Now, I want you all to remember the median of a triangle goes from where to where. It's going to go from a vertex to the midpoint of the opposite side. So I'm just going to say this is our midpoint of the opposite side. And we see by the markings on my figure that shows that it is the midpoint. Now, when we're talking about the mid segment of a triangle, we learned that a couple of sections ago. It is going to start from the midpoint of one side of the triangle, and it's going to join to the midpoint of the other side of the triangle. And we also learned that it's parallel to the third side of the triangle, and it's also half the distance or half the length of that third side of the triangle. So we do have a theorem about the median of a trapezoid, and the theorem tells us is that the median of the trapezoid is going to be parallel to the base. So we can go in and write our parallel or draw in our parallel symbol so that we see that we have these three lines that are parallel, and that median is going to be half the average length of the bases. Or one way to say this is that if I called this base 1 and this base 2, then our median here is going to be 1/2 of base 1 plus base 2. Or another way to say it is that the median is going to be base 1 plus base 2 over 2. And you may have remembered in the past when you've learned or if you've talked about area with trapezoids, we really do use this quite a bit, and it's built upon when we are coming up with medians of, areas of a trapezoid. So we did go over a few things today about trapezoids. First, by definition, they are a quadrilateral with exactly one pair of parallel sides, which means that a trapezoid is not a parallelogram. We also learned that an isosceles triangle, by definition, has congruent legs. And then we learned a theorem that the base angles of an isosceles trapezoid are congruent. Then once we learned what a median or a mid-segment of a trapezoid is, which is just the segment that joins the two midpoints of the legs, we learned that the median of a trapezoid is going to be parallel to both bases, and that median of the trapezoid is going to be the average of the lengths of the bases. Or you can say it's 1/2 of base 1 plus base 2, or you could write it as base 1 plus base 2 all divided by 2. So what I'd like for you to do now, you can work on this problem here, solving for x, and then these classroom exercises. And once you're done here, you can check your answers in the content library, and you can also feel free to work with others on solving these.